Ladies and gentlemen, welcome to another episode of Science Without Consensus, exclusively on Rumble, 8 p.m. Mountain. I am your host, Diamond, from the Oppenheimer Ranch Project. Joining me is my lovely partner and co-host, Leah Shaper.
Hello.
And that's Saturday, 8 p.m. on Rumble, as we rumble in the jungle. Thank you all to our new Rumble followers. And if you're not a follower and you got here somehow, hit the follow button already. Why won't you? We got a great show. We're going to be talking about tons of topics. The first and foremost, because it's happening right now, will Hurricane Melissa trigger a major earthquake? And why am I asking that question? Because a year ago, almost to the day, another hurricane that moved over that area triggered a massive earthquake. And it was a 1-2 punch. So the earthquake destroyed homes and the hurricane destroyed everything else. So is that going to occur again? And why does it occur? It has to do with electric universe and these low pressure systems moving over faults, triggering these earthquakes. We'll also talk about the latest news with 3i Atlas. No, it's not a spaceship. Also, some new information about a centaur in our solar system called Chiron, which now may be forming rings. This was a strange object that they called a blend between an asteroid and a comet when they first discovered it. And that also has ties to electric universe. So we'll get into that. Also, a 10,000-year-old crater was recently found in China. We will discuss the implications of that. More and more things seem to be hitting the Earth than we're aware of. And we've also got a medieval tsunami redated to the 13th, what would that be? The 14th century?
Yeah.
In the Caribbean, and the oldest structure ever found on Earth, which is mind-blowing because I don't know how it's not broken or anything. It's just mind-blowing, but it is kind of thick. So there is that. We'll get into all these topics and more, hopefully. Are you ready to rock? You have anything to say?
No, let's get into it. We got a lot to cover.
All right. I didn't even share the screen yet, so I don't. Oh my God.
What are you doing?
What am I sharing? Let's do it. All right, so here we are. Here is the current track of Hurricane Melissa. It is currently a weak maximum sustained winds at 75 miles per hour hurricane. It is going to become a major hurricane in the next 24 hours. That means Cat 3 or greater. And it is just going to linger here for days, 3 days off the southern shores of Jamaica. And there are some rainfall estimates. Well, let's go see what the current ones are that are showing over 20 inches. Look at that, 20 to 30 inches for almost half of Jamaica.
Oh my God.
That's bad news.
Oh, that's going to be a disaster.
So let's take a look at the tracks. All right. So it's going to linger here for 3 days south of Jamaica and then move directly across Jamaica in 4 days. And then it's going to go over the eastern tip of Cuba as it makes its way out into the Atlantic. So there's going to definitely be damage and flooding in Cuba as well. Here is the bad thing. The last time this happened, a major earthquake was triggered as well. Here's the paper from last year. Cubans tested to the limit as earthquake, hurricanes, and total blackout hit within days. So is that going to happen again?
Where is the fault exactly?
Well, here you can see Jamaica. There is a minor strike slip fault in green that runs through Jamaica there and into southern Hispaniola. But the main threat is the yellow fault here. If we travel off to the right here towards Cuba, towards Puerto Rico, if this fault becomes the Puerto Rican Trench to the north, and any of these trenches can any of this fault can cause tsunamis.
Yeah.
And we're going to get to that topic because this is the fault in question that caused a major tsunami back in the 1300s.
Yeah.
And this is also the fault that caused the major earthquake as a hurricane moved over Cuba last year, almost in the same area.
Yikes.
So will it trigger another earthquake? That's the question.
I mean, it's crazy too, because it's either one of these faults hard enough and you get a tsunami going towards the other place, Cuba or Jamaica, you know?
Yeah.
And it's in such close proximity that obviously that tsunami would be devastating.
Right. And it would hit immediately. There'd be no warning because the fault is right on the shore.
Right. That's what I mean. Yeah.
So here's where the 6.8 triggered last year. And then this hurricane is going to be moving more in this area, which may have some pressure in it.
Yeah.
Now, what's also interesting, I pulled up the Cuba quakes, and I don't think I have that up here right now. Darn it. Oh, no, here they are. And what's interesting, it seems like these earthquakes occur in clusters. So there's a 1580 and a 1578, 2 years apart. And then a 75 and a 78 and a 79 and an 82. That's a cluster.
Mm-hmm.
And then 1757, 66, cluster. 1842, 1852, 1852, 1858, cluster. And we've got a 2020 and a 2024. So we're developing a cluster.
Yeah.
And you can see there's lulls. So there's only 4 earthquakes going back to 1947.
Yeah.
Yep. So cross your fingers, Cuba.
Yeah. Yikes.
Godspeed. Anything else you want to talk about? Hurricane Melissa?
Well, I mean, just this idea of a hurricane triggering an earthquake. I mean, I don't think we generally think enough about the connections and the type of energy involved in a hurricane and an earthquake, right? Like we've talked in the past about the idea that sunspots sometimes correlate with storms on Earth, right? All of that energy is related. You know, these are not all different things. This is all electromagnetic energy at the end of the day, that has far-reaching impacts.
Yeah. Is it triggering the telluric currents along the fault as the low pressure moves over it? Because the low pressure system that is the eye of the hurricane is similar to a sunspot. Is it the electrical nature of the two as it moves over that it triggers it? Or is it the enormous amount of pressure or suction that it's sucking up the earth, the plate, and that may release? It could be both.
Yeah.
Yeah.
I feel like our understanding of that is like really primitive.
Yeah.
And certainly not well connected in mainstream science. I think it would be more easy to connect if you're using an electric universe model.
Yeah. But it was observed in this very area 1 year ago.
Yeah. Yeah. But but it's a very good reminder too that weather, period, is an electromagnetic phenomena.
Yeah, exactly.
Yeah.
So let's see what happened. It doesn't really give any stats on how many homes were crushed. Oh, well. Just say, what I can say is buckle up.
Yeah.
Jamaica, Haiti, Dominican Republic, and Eastern Cuba all going to be affected, and they're going to be affected for the next week. That's how long it's going to take before it moves out.
Yikes.
Which is why these rain totals are insane. That was just the 4-day rain total.
Yeah.
So this pink area moves with the storm as it moves this way.
Yeah.
So that's just the next 4 days. And 2 or 3 of them, it's just going to be hovering down here south of Jamaica before it turns and moves away.
It looks like Haiti's going to get some of the worst of it.
Yeah, this peninsula here.
Yeah.
I forget what they call it. So
even the main area too, assuming that track is correct.
Yeah.
That looks rough.
Yep. All right. Prayers go out to everyone in the path.
Yeah.
Now let's get to the spaceship. There she is. So this is a recent image of Comet 3I Atlas taken by the Gemini North Telescope. That's the image on the left. This is alongside the new 2-meter twin telescope image of a jet erupting from the comet in the direction of the sun. Now, do you see a jet erupting from this comet?
Actually, I don't. Except
so
for I know that the purple line is supposed to indicate a jet, but I don't actually see it.
right.
Except for
So
this opening, right?
if you
In the
look at
coma.
this, it's not a circle, it's an egg.
Mm-hmm.
So the pointy end of the egg is the jet.
Right.
It's very mild.
Actually, you can kind of see it in the photographic image too.
Yeah.
It's very faint, but you can also see this kind of opening in the coma where the jet comes out, which is interesting.
And they're saying that this is because it's being warmed by the sun based on zero evidence whatsoever except this picture.
I mean, even in the mainstream model of sublimating ice and all of that nonsense, it really fails to explain. Well, I mean, we know this, right? We've talked about this in terms of when comets brighten or supposedly sort of erupt or whatever. But just like, look how bright that is. Like, doesn't that inherently suggest
That something
that
else is going on there.
there's like an energetic phenomena happening here, like largely energetic, that
Well, let's
is
read the article here and then comment.
electrical?
Let's read the article and comment on what they say.
Yeah.
It says an interstellar comet is dramatically jetting off ice and dust into space, a new image shows. I mean, that is pure speculation.
Mhm.
100%. And it's speculation based on a model that hasn't held up to any of the observations in the last decade.
Mhm. But yeah, we're going to continue to say it with definitive certainty.
Yep. And here's more definitive certainty. The comet called 3I Atlas is sending out a jet of material towards the sun as our nearest star warms up some of its surface. This thing is millions of miles away from the sun.
Right.
It's probably absolute zero where it's at. And they're saying that the sun is warming up the surface. Absolute insanity.
Mhm. I mean, the sun can't even melt our polar ice caps.
Yeah. And this is at least twice as far away.
Right.
Has no atmosphere. Therefore, it is in space. And it's probably, yeah, it's crazy.
That's so silly. But I love it too when I was listening to a video this morning that was actually talking about Chiron, I think, which we'll get to later.
Yeah.
And um, everybody continues to say that the eruptions or the jets that form, like it always happens when it's closest to the sun, and that's not even true. Right? Like there's an incident with Chiron when it's at its furthest point from the sun. So what are you talking about? That's not true across the board by any means. So to continue to say that the proximity to the sun is the thing that triggers these jets is really stupid.
Yeah. It says
Now,
the composite image shows the nucleus or icy rocky central core as a large black dot along with a white glow, the comet's coma or atmosphere. The jet is marked in purple and is blasting off towards the direction of the sun, which is typical behavior of comets in the solar system as well. Now, what's actually happening here is there's probably no ice and it's a rock that's electrically charged and it's moving through an electrically charged environment that it is not used to. It did come from a different solar system, for goodness sakes.
Mhm.
And it is electrically discharging within our solar system's electrical environment.
Yes, it's unstable. It's electrically unstable, which is why it's doing things.
Otherwise, we would call this an asteroid.
Right.
Because it wouldn't be doing anything.
Right. Because it would be stable.
All right. Great show. Yeah. Do you want to beat the dead horse on this or do you want to head over to Chiron?
No, let's talk about Chiron.
All right. So, in conclusion, it's an electric comet.
Mm-hmm. Low and
All
bold.
right. Here's the article that came out. These all are this week, all these papers and articles. A strange object between Saturn and Uranus is evolving its own ring system, according to a new study. There we go. That's a pretty fancy artist interpretation. We don't have any pictures, actually, of this Chiron. We've never been too close to it, but we do have like pinprick images from satellites or telescopes. My bad. Okay, so what are rings and why are they there? That's what the question we should be asking.
Yeah, agreed.
As far as Saturn is concerned, there's so many rings on Saturn that lots of them are debris fields. But they're all held in these narrow bands, just like this artist's depiction of these probably debris fields in these bands, almost as if it's tuned, almost as if it's mimicking an atom with orbitals, you know? The objects have to be there because of the charge is keeping them at a particular area.
Yeah.
And that would mean that each of the rings represents a different charged object that broke up.
Yeah.
Yeah.
It could also be just plain old debris, right? Like, let's say
that it's sucking in from space.
Or like if there was some kind of plasma interaction with another body that blew off some material and then that ends up settling in a ring because that's the electrically stable position for that material.
Right. I think it more likely this moves through like comet debris fields and accumulates this dust as it encounters it. Now, this is called a centaur. Have you ever heard of that word before?
Yes.
A centaur go ahead.
I was just going to say it's called a centaur because it's sort of considered to be a cross between an asteroid and a comet, right? It kind of behaves like a comet. It kind of behaves like an asteroid. So
like when you Google centaur, you're not going to get this information. You're going to get the mixed animal hybrid in mythology.
Well, which is what it's named after, right?
Exactly.
Like Chiron was a centaur in Greek mythology.
Oh, where am I? Okay. So in planetary astronomy, a centaur is a small solar system body that orbits, this is important, that orbits the sun between Jupiter and Neptune and crosses the orbits of one or more of the gas planets. So, what does that mean? Here's an image.
That's the fun. One of the funny things about Chiron that's notable and quite important, I think, is that most of the time it's between Saturn and Uranus, but the orbit is elongated in such a way and kind of like off center almost that part of the time it's outside the orbit of Uranus, in between Uranus and Neptune, and then part of the time it's in between Jupiter and Saturn for short periods.
Yeah, and here's some this is a pretty cool visual. That's not it. How come I'm not? What's going on?
I saw a really nice image of its orbit earlier today.
I'm not sharing screen anymore.
Uh-oh. Better hit the button.
How long has it been like that?
No, it was only while you were changing screens. We're sharing an image right now.
So here's a couple dozen of the centaurs we know of, and Chiron is the third largest. Look at this. Is that the name? Yeah.
Chariklo.
So Chariklo is the biggest. Pholis is second. And then you got Chiron and 2022 GZ.
Don't forget 2005 RO.
Yeah, that's an important one.
Yeah.
So clearly something happened out here. Where are we? All right, let's share this. Clearly something happened out here. A huge cosmic catastrophe occurred outside of Jupiter. And it's pretty significant because all the pieces are pretty small.
Yes. And also, by virtue of the fact that these are all centaurs, they're all clearly electrically charged.
Yep.
which leads me to think that this is a function of a captured comet.
That disintegrated somehow.
Yes, like perhaps it had a collision with another body, broke apart. That was Velikovsky's theory, right, about Venus, was that Venus was once a comet that was captured by our solar system. And so one of the things that I find really interesting about this object is it is its sort of unstable orbit, right? It's like and in conjunction with the rings that are forming and still developing, right? Because there's some data that was looked at a decade ago for Chiron and this material outside of Chiron, and it was different then. There are changes. There are new things happening. So this is a body that's unstable and still working towards its stability. So that's part of the reason why I really think at this point that that's what happened here is we had some kind of captured comet. We have a bunch of bodies that are still electrically charged, and they're moving towards developing a stability with the rest of the objects in our solar system. That's what it looks like to me.
Yeah, well, and take a look at this. So, am I sharing the screen? Yeah.
Yes.
The centaurs are in here. And this is a comet that we know of called 38P Stefan Oterma.
Mm-hmm.
And it comes and its close approach is right in the orbit of the centaurs.
Yeah.
So that means we've basically proven that a comet came in and hit something and then was captured and created this debris field.
Well, and perhaps the collision
because
itself,
we have other comets that come right in there. So eventually
yeah,
this comet is going to hit Chiron.
Right.
Yeah.
So it sort of suggests that the reason for the capture in the first place is a comet entering our solar system, and then its orbit gets disturbed by a collision.
Yeah.
Which, so the electrodynamics of its orbit originally would sort of overwhelm the electrodynamics of our solar system and it would leave. But when there's a collision, the whole thing gets disrupted, has to restabilize, and it becomes subjected to the electromagnetic conditions of our solar system. And in the case of Chiron, this obviously happened a long time ago, but it's still stabilizing. That's how it appears.
Yeah, and it's not discharging like most comets.
But it is.
Well, yeah, in a sense, it has a major electromagnetic field, which is creating these rings, but there's no plasma discharge that's visible.
There is a coma, though, and I thought I recalled reading that occasionally it does have a tail.
Oh, wow. Let's go. Let's read.
Yeah.
Let's go.
So I think this paper mentions both of those things. And,
well, here, check this article I found.
Yeah.
This was published January of this year. Scientists left baffled after discovering asteroid comet hybrid like nothing ever seen before. And this is Chiron.
But Chiron was discovered in 1977.
Yeah.
So that title is a bit of a misnomer, but
say again.
That title is a bit of a misnomer. So perhaps it
says right in the article that it was discovered in 1977. So Chiron, now we know, is 125 miles wide. So it's pretty significant.
Mm-hmm.
And if that were to hit another comet, that would create a debris field.
Yeah.
And then it goes on to lie here and says that Centaur's surfaces are CO2, methane, and frozen water.
So
that all predate the formation of the solar system.
So here's the maybe the tricky part. So my understanding, and maybe I'm not quite right about this, is that in the coma of Chiron, they are discovering those compounds.
Yeah.
Now, that doesn't mean necessarily that Comet is doesn't necessarily mean that Comet is another icy snowball, right? Because lots of things can happen chemically that affect what the coma is. Okay, like for example, there is water in Earth's atmosphere, but Earth is not, an icy snowball. Obviously, it has water. There's the components of water, at least for Chiron, if it's being detected in the actually no, I'm not sure it was detecting water, but certainly CO2 and carbon monoxide.
Yeah, and here is an artist depiction of Chiron and its tail.
Right.
That's crazy.
Right. So here's the other thing, right? That they're talking about as of, when is this paper written? This is this month, 2025. So I guess that article is pointing to this paper. So they're talking about the Roche limit. So they're talking about the rings, and that they think they're what they're saying is that they're finding rings around outside of what would be the Roche limit for this object. So they're using a gravitational model to say that at a certain distance from Chiron, we shouldn't find rings, we should find a little satellite of some kind, that all of the matter that's out there should have coalesced into an object, which personally I find to be a ridiculous idea in the first place. But
yeah, so these rings, so the object is how big? 125 miles across?
Yeah.
The rings are 170 miles away and 270 miles away, respectively. Two of the big ones.
There's 3 rings total that they can see right now.
Right, so yeah, the other one is 500 miles away.
Right. So they're like, well, this, according to our math, this shouldn't work, but maybe we just don't understand Chiron. But it's also like, okay, well, maybe your math is wrong. Like there might be the mathematical calculation of that limit might be appropriate for a planet, say, that's in a stable orbit around the sun, but this object is not stable, has an unstable orbit, so it's acting differently. So the Roche limit is only going to apply in a certain situation, and it may just happen that it works with the gravitational math. But if all of this were looked at from the perspective of electric universe, and I'm just speculating here, but I would bet anything that we would find that the existence of these rings in an object like this that is unstable would be completely appropriate.
Yeah, I agree. And just imagine if Saturn's rings were 3 times the diameter width away from it, how big that thing would look.
Yeah.
So this object is very strange, clearly electrically discharging, and has these orbital shells of debris around it that don't meet gravitational models, and scientists are baffled as usual.
Right. But it does also suggest something else that we've been talking about here and there, which is like that there's kind of this spectrum between the nature of objects in our solar system, right? Like we have speculated that, asteroids and comets aren't in different, like materialistically, they're just these rocks, but one is electrically charged and the other one is not. And obviously there's some amount of charge for the planets in the system, but it's nowhere near the level of a comet. And so this object seems to be kind of like an intermediary, right? Like we're postulating that it came into our solar system, something happened that led it to be captured. Now it's gradually becoming this object that has more stability. And I would propose probably loses a lot of its charge in the process of that being the case, right?
At some point.
Right. Or it starts losing its electrical potential, I guess would be the more appropriate way of putting it.
Yeah, and it travels around the sun every 50 years. So that's a very long orbit.
Yeah. But then it's
take
also
1,000 orbits to stabilize, which is 50,000 years.
Right.
Yeah.
And then the other thing that's super interesting, right, is you have this scalar phenomena that's happening here, right? Like you said earlier on in this conversation, pointing to the fact that this, it kind of looks like what you would imagine is happening with an atom. And in fact, the rings are particularly appropriate, right? Like the original sort of atomistic model was that you have these little electrons, like particles that are circulating around the nucleus of the atom. But when you look at it from a quantum mechanics perspective, what you really see is just the probability of that electron being in a particular place at any moment. And these rings are kind of like that, right? It's like, well, whatever. I don't need to get into all of that. But then this also looks like what would happen with, another planet with rings, but our own solar system, right? It's
Yeah.
like as if the sun is the nucleus and the planetary orbits are the rings, and
It's all
and what
plasma
their
scaling.
probability of being in any particular location is at any given point in time.
Yeah, those rings are exactly where they are supposed to be.
Of course they are, because it's the universe and God doesn't make mistakes.
But according to the standard model of cosmology, those are all haphazardly where they are for some strange reason.
Right. It's all just like this head scratching thing. And yeah, this doesn't meet the Roche limits.
It can't even exist.
It's like, it's kind of obvious that the Roche limit is not important and kind of meaningless. Like, yes, it may have some utility in talking about objects that are in stable rotation around the sun, like our planets, but it's not, you can't extricate that to everything else, right? Good science provides an explanation on every level. Like, not that you have this situation where you have to change the rules for every level of science or every different object in the solar system. Like, that's not good science. That's the indication that cosmology and astrophysics needs to change, because none of the rules apply universally ever. It's ridiculous. I mean, it's gone so far that I've heard many people in science say things like, well, this idea that we can have a unified physics, it's just not possible. Like, we've given up on the idea of a unified science simply because we've gone so far in the wrong direction that we're not working on anything that's going to get us there. So we've said, oh, that's just this unrealistic ideal. I don't think that's the case at all. I found myself getting sucked into that for a long time too. Like, before college, I was really into the idea of a unified science. And then I studied physics in college, and it was like, oh, I guess this isn't really feasible. But eventually I came back around to the idea that, like, no, it's just that the science isn't very good.
Yeah, we've been using uniformitarianism for over a century, and it's wrong.
Right.
So when will that change?
Right. Yeah. But as Thomas Kuhn taught us, it takes a really long time to initiate paradigm shifts for a variety of reasons.
Maybe we need an asteroid to hit.
Right?
So like a crater suggests an asteroid hit Guangdong 10,000 years ago with a blast like 40 atomic bombs. What are your thoughts?
I'm not surprised. I'm sure there's lots of craters all over the Earth that we haven't noticed.
Well, this one is so obvious. I'm like, really? Some dude camping just figured this out?
I mean, this is in China. China's a really big place. There's a lot of Earth to cover. And it just so happened that no one who was seeing the crater here happened to come here until recently.
Yeah, this is just a fantastic example of an object hitting Earth, leaving a perfectly shaped crater, very similar to the one that's here in the Southwest. Meteor crater, it's called. I think that's in Arizona, isn't it?
I don't know.
We should go.
Yeah.
So
but this is a young crater too, which is cool because you can really see it because it hasn't been subjected to a lot of erosion.
And it's like in a jungle, so it's amazing that it's that crisp.
Yeah.
So they did confirm that a large crater in China's southern Guangdong was formed as a result of an asteroid impact around 10,000 years ago. I'm going to go out on a limb here and say 12,008, maybe.
I was wondering about that.
Yeah. This could be part of the Younger Dryas impact, and just a small piece that didn't hit the ice sheet but hit China. Because there are craters all over that are dating to that, and we certainly haven't found them all.
No.
What's interesting is the huge chunks here you can see in this matrix. Here's another one. So just a catastrophic event there. It's named the Jinlin crater if you're ever in China and you want to go check it out. It's located near the city of Zhaoping. It's just the 5th confirmed impact crater in China and the first one to be identified in the country's southern region. It has a diameter of 900 meters, which is like 2/3 of a mile. And And the team determined it was likely caused by an object around 100 feet across. So that's a tiny rock.
Mm-hmm.
Can you imagine if Chiron hit us? That's a yeah.
That'd be pretty devastating.
So a tiny little rock creates a huge crater.
Mm-hmm.
The energy released by the impact is estimated to be 600,000 tons of TNT, according to Chang Ming, whoever that guy is. That's equivalent to the power of 40 Hiroshima-sized atomic bombs. Which is not that big of a blast these days. We have nuclear warheads, I think, that are 200 times, single warheads that are 200 times the Hiroshima bomb.
It's terrifying.
Absolutely terrifying.
Well, and also worth pointing out that, as usual, they looked at, quartz, shocked quartz, etc.
Yeah.
To determine that this really was an impact site.
The crater is about 300 feet deep. And you're correct. To confirm the impact, the team studied quartz samples from the site for the presence of planar deformation features or planes of glass that form within a crystal when its lattice structure is broken. Okay, absolutely fascinating.
Yeah. Well, clearly we get hit more often than is acknowledged.
Yeah.
I don't think it's an accident that, we often have like thriller movies about, asteroids hitting Earth or whatever. It's kind of like all the zombie movies. You have to, at some point, conclude that we have some kind of like genetic memory of something zombie-like happening at some point in human history.
Yeah.
Might even be having one of those now, but that's another subject.
Yeah, and we may just all need to pray for an impact of Chiron.
I mean, if Chiron were to impact Earth, wouldn't you think like probably an object that size hitting Earth, I feel like would wipe out most of the life on Earth, period.
Yeah, maybe all of it.
The amount of debris that would end up in the stratosphere would be just off the charts.
How big? I think Chicxulub is 65 miles wide.
Oh, is it really that big? And it didn't even actually hit the ground.
Yeah.
Oh, no, yes, it did. What am I saying? I was thinking of something else. Never mind.
Created a huge hole.
Yes. The Bay of, what is it called?
About 10 kilometers, 6 miles in diameter. 6 miles.
6 miles, not 60.
6 miles. And that almost ended all life on Earth.
Right. So the Earth is done. If we get hit by Chiron, which will never happen, just based on its current orbit. I mean, unless something else comes along and knocks it out of its orbit, but that's not happening.
Yeah. So 3I Atlas is over twice as wide as the Chicxulub object. So that would probably end everything on Earth.
Which is interesting because
the shockwave that would wrap around would kill all mammals.
Right.
Your eardrums would explode and your eyes would pop out.
Right. That tells us something, though, about the size of whatever object or objects were involved in the Younger Dryas event, right? Because that sort of tells us that those objects probably weren't that big. But
no, there are probably just thousands of them.
Yeah.
Like all the re-impacting ice that got blown into space is a million more objects.
Right. So again, it kind of screams, Younger Dryas kind of screams a debris field that we entered.
Yeah.
Like a relatively recent one, probably.
Yeah. It may be the Taurids.
Well, this is an interesting.
They're estimated to have originated around 40 or 50,000 years ago. The parent body, and if it began breaking up then, and the final event was the Younger Dryas, it explains all of the flash frozen animals in the Arctic from 50,000 to present. That as the pieces hit, these catastrophic events occurred, and we flash froze these animals locally in certain areas. And then the last time we went through the field was 12,800 years ago.
Right.
Thank God.
Well, I mean, this is interesting too, in light of the fact that we think here in our particular location on Earth, we think recently we've experienced a couple of little sonic booms that may be meteors in the
Yeah.
atmosphere above us, which has been very strange. We've been trying to figure this out with a friend of ours that lives nearby, and it's definitely interesting.
Yeah.
And this makes sense because we are in the middle of the Orionids and the Northern Taurids. I mean, the Southern Taurids are happening as well, but in the Southern Hemisphere. So maybe we just happen to be in the right place on Earth to experience some of this right now. But, just even doing a little searching around the internet, there's plenty of videos of people experiencing similar things, like some kind of explosion. And they're like, what's that? And it's this short-lived thing. And then you never really find the answer. And perhaps that's what those people were experiencing as well. I mean, obviously some of those things can be other phenomena, like, exploding transformers or something like that. But
Yeah, but this sounded like a sonic boom to me.
no, this was like a sonic boom, no question. And it shook the earth and it shook the house. So that's interesting. So I mean, altogether, clearly we're in danger from impacting objects all the time.
At
I mean,
any
the moon
moment.
shows us that clearly.
But we're also at danger of tsunamis,
Yes.
especially if we live along a coast by a fault.
Yes.
This paper coming out the 8th of October this year, dating a medieval tsunami with uranium series techniques on Caribbean corals. These corals have been known to exist, and they are hundreds of meters inland on the islands. Let that sink in. This coral probably weighs 200 to 300 pounds, and it was moved hundreds of meters inland. What force would you need to do that?
Mm-hmm.
Or to break off a coral of this size?
Mm-hmm.
What kind of force would you need?
I'd say that's probably more like, oh, well, it's a coral, so it's not going to be that dense. Yeah, 200 to 300 pounds would make sense. If it was a rock, I'd say that's like more like 500-600 pounds or more.
But coral's still pretty heavy because it's calcium carbonate. It's calcite.
Sure.
Yeah.
Sure.
So you're going to need a tsunami. And they knew these tsunamis occurred. They just didn't really pinpoint when they occurred.
Mm-hmm.
So this paper and the dating techniques they used gave them some high resolution dates. And the tsunami limits are between 1381 and 1391 and likely occurred during summer or fall. So what are your thoughts?
Was the time of year determined somehow by like the state of the coral skeleton?
Yeah, you can tell if they have growth rings like trees.
Right. Oh, right. Okay, yeah.
So it was probably in the process of growing its next ring, which is why they said it happened in the summer.
Yeah.
Yeah.
Or like right after the growth ring formed, if the summer, assuming the summer is the highest rate of growth.
Yeah.
Yeah. Interesting.
Yeah. So major tsunamis occurred, and this one occurred on the Puerto Rico Trench. We should go take a look at that.
Mm-hmm.
Because this ties right back into the first story.
Yeah. Well, isn't that trench potentially going to amplify the tsunami as well?
Well, it's right. So it's right here off the shore. So it's going to be there in five minutes.
Right. Okay. Yeah. Yeah.
And if an earthquake happens here, north of Hispaniola, north of Santo Domingo, it's going to hit in a minute. Look how close that is.
Yeah.
And now we've got a hurricane that's going to move over Jamaica and move over eastern Cuba. And that fault is right on the shoreline there.
Yeah.
So that could be an instantaneous tsunami on Cuba. And then 10 minutes later, Jamaica and Haiti.
And it'll happen.
Do you see this bay, how it constricts in here?
Yes, that's very bad.
That is going to magnify the wave, and it will be devastating.
And the tsunami would occur, and an earthquake and tsunami would occur after the storm, obviously after the storm passes over. So it's like you're just recovering from the storm, and then it's like, boom.
Simultaneously while the low pressure is on the fault.
Right.
Yeah. Crazy.
Well, I meant for like Jamaica, for example, it would be after the storm passes.
Yeah. So
Yeah.
everything is destroyed, and the next day a tsunami wave comes and destroys everything again.
Just as you're
Absolutely
breathing a sigh
insane.
of relief
So
that
we're
it's
praying
over.
for all those people out there.
Yeah. Yeah.
Anything else you want to cover on the paper and the crazy giant corals hundreds of meters inland?
No, it's pretty fascinating though. And,
Yeah,
and obviously you know, a distinction has been made that these corals were carried. You know, this is not a function of a receding coastline or something like that.
right.
Yeah.
Yeah. They were catastrophically placed. And you can tell because they're sitting on the current soil surface, which was also the surface back in 1391 when the tsunami hit.
Right.
Yeah. All right. This last story is pretty cool. It's mind blowing. Now, as a geologist, I know we have very old rocks on Earth. That makes sense. Some of the oldest rocks are billions of years old, but this is the oldest structure ever found. And the oldest man-made structure we've talked about is about 400,000 years old. That structure in Zambia.
Or Namibia, one or the other, or
It's
Zimbabwe.
Zambia, but I forget what it's
I
called. It's
never
called
remember which one it is.
something structure. But this structure is 289 million years old.
Well before humans and even before dinosaurs, for perspective.
Yeah. This is right after fish and amphibians. And so this stalagmite, so this giant thing right here. Can you see my cursor?
Yeah.
Okay. Yeah, that is a very old structure. It is a 289 million year old stalagmite, and it's in Oklahoma. And that is the key. So I'm going to quiz you in a minute.
Don't quiz me. I hate that.
It's a remarkable find that challenges our understanding of ancient Earth's climate and evolution. So the discovery of the world's oldest stalagmite. Now, a stalagmite is the opposite of a stalactite. Tites hang from the ceiling, and mites are beneath them, and they grow from the floor. You knew that. You learned that. Didn't we learn that like in 8th grade?
I never remember which one's which until I have to go back and review it every time. But yeah.
So this stalagmite in Richard Spur, Oklahoma, is making headlines, dating back a staggering 289 million years old. It is not only a geologic wonder, but also a key to understanding ancient climates, because this baby is just like an ice core. They could take a core sample out of it, and they're going to get high resolution climate data from 290 million years ago. That's insane.
I mean, it also tells you that this cave has been here that long.
Right. And the key is Oklahoma. If it were anywhere else, it probably wouldn't be there.
Why?
This is in the middle of the North American plate, as middle as you can get.
Got it.
Nothing going on here.
Nothing geologically going on.
The sea level doesn't affect it. It is
Right.
in the middle. So the only thing that can affect this is groundwater, and it's a cave. They need groundwater. So perfect placement. So this must be, because it is, the oldest cave in the world.
That we know of.
Huh?
That we know of, anyway.
Yes, that we know of. Which means there could be older ones.
Right. Well, and then the other question here is, this cave, as we just said, clearly is at least 289 million years old. How does the geochemistry in a cave reflect the climate outside the cave? Right?
Well, we know that, but from watching active caves today and how they change. So there's, ways to sample the calcite, the dissolution of the calcite, to find different concentrations of minerals, to know if it's wet or dry, when they're growing. So you could date each of the layers in the calcite. And, so it might grow for 10,000 years and then stop for 1 million.
Because it's too dry.
Yeah. And then grow for 10,000 and stop for 1 million.
Right.
So this is going to be a fascinating thing to study. I wonder how many samples they'll take from it.
Yeah. Yeah.
All you need is a tiny little core sample through the whole thing, and everyone can work off of that.
Yeah.
Yeah. So that's fascinating. It also shows you that this stalagmite, not a tight, because if it were a tight, the reason it's not a tight is because they always break off. There's earthquakes here. The stalagmites are fatter knobs. So it's going to be hard to break that off during an earthquake. But something dangling from the ceiling will fall, because look how fragile these little stalactites look.
Yeah, well, because also with a stalagmite, right, just a drip on top is going to send some material down the sides, which is going to contribute to its width, which is just not going to happen for a stalactite.
Yeah, their stalactites are thinner than mites. Yeah. Yeah, that's just fascinating. The samples they have started to study will allow them to re-examine the terrestrial vertebrate fauna at Richard Spur within the context of the first absolute age and direct paleoclimate data for the early Permian. That's a mouthful. Did you take a look? Go ahead.
I wonder if stalagmites might reflect the magnetic field on Earth at the time. Do you know?
Calcite doesn't lock that in.
It doesn't? Okay.
It's not a magnetic mineral.
Right. Okay, of course. Right. Because it's not metallic.
Yeah.
Right.
But I wonder if you can go in the cave.
What is the name of the cave?
There are walkways in the picture, so you must be able to.
I mean, I saw like there's like a virtual tour and tunnels.
Yeah.
The Lehman caves, Lehman or Lehman. It's Lehman.
Yeah.
We should, if we can tour this thing, we should go do that sometimes.
Well, the closer one is Carlsbad, and that is the biggest cave on Earth, I think, or in the United States.
Excuse me.
Yeah, that Carlsbad's the biggest cave in the U.S., I think, other than Mammoth in Kentucky, but that's a different type of cave. Carlsbad is huge, where Mammoth is a bunch of small tunnels that go for hundreds of miles. Yeah. But Carlsbad is right next to Ransom. We could all go. All right, the paper coming out a long time ago, Speleothem Climate Records from Deep Time, exploring the potential with an example from the Permian, will be linked below. We got a video here. Oh, that's too long. Well, do you want to look a little bit in Lehman Caves? You want to take a look?
Yeah, let's look.
Let's look.
Just fast forward a bit, because the beginning of it is all tunnels.
And so we don't want to get a copyright strike here. So I'll just turn off the music. And here we are inside of the caves looking at none other than a stalagmite.
We're not sharing the video.
Oh, okay. Okay, I'm dumb. Let's go back because I want to say stalagmite again. There we are.
There we go.
Looking at a stalagmite right there in all its glory. And we got some flowstone behind it. Pretty fascinating. More stalagmites. And if you have a stalagmite on the ground, these bumps, there's got to be a stalactite up above it unless it's fallen down. That makes sense, doesn't it? All right, let's fast forward to some more cool formations in here. Look at this.
Stalagmites.
And when they connect, it's called, what do you think? A column with an N. A column. Wow, that's just amazing. Can you imagine like the first early humans lighting a torch in here? What they must have been thinking?
One end of this cave is called, what is it called? Like something castle.
Because of the formations?
Yeah. Or the cathedral or something like that. Beautiful.
Yeah, they name formations in caves. And if you're the first one to find it, you can name it. Similar to geology. Look, that's the cathedral. Absolutely beautiful. All right. It was a great show. Anything else we want to hit on before we head out?
Mm-mm.
All right, guys. Thanks for watching. Share this video. If you're not a follower, you can follow us below. 8 p.m. Mountain Time every Saturday.
On Rumble.
Magnetic Reversal News on Rumble. And we'll replay it during the week on YouTube. Be safe. We love you. Bye now.
Bye.